All right, good afternoon, everybody. I think we'll get started with the event. Thank you for joining us for the second of our National Construction Code Roundtables. My name is Michael Woodhams and I'm coming to you from the land of the Gadigal people. Wherever you are, I'm sure you'll join me in acknowledging the traditional owners of all generations. If it's raining, I hope you're staying dry. Now, we're fast approaching the deadline for submissions to the current review, which is on the 1st of July. So if you're going to make a submission of your own, I hope you've got that underway. The Institute will obviously be making a submission, and that's one of the reasons why you're here today, to help inform our input. Waterproofing and watershedding are fundamental aspects of that. And as we review and discuss potential improvements to the code, your insights and feedback are going to help shape a robust and effective regulatory framework. Today, we aim to explore the challenges, potential solutions, and innovations in waterproofing and watershedding practices. Now, before we get into it, let me introduce our three speakers. All three of them, in fact, sit on the New South Wales Building Commission's Watershedding Community of Practice ABCB Technical Reference Group for BCA Section F. Now try repeating that without having it written down. Firstly, Craig Burns, Technical Director, BVN Architecture and the Institute's representative. 35 years experiencing things going right and things going wrong. His words, not mine. Ross Taylor, Managing Director at Ross Taylor Associates, a highly regarded waterproofing expert with decades of experience in both contracting and consulting. His words, not mine, but I'm sure they're true as well. And Michael van Koeverden, Civil Engineer and Engineers Australia Chartered Fellow and Director at CQT Consulting Services and Engineers Australia Representative. Welcome to all three of you. Craig, would you like to kick things off?
Sure.
I'll stop sharing. Now, just actually, before we do, I might, if anybody hasn't seen the QR code, which will take you to our Google Forms document for you to submit feedback, please do. But many of you will have already seen that before and will be putting feedback through. You can also do some feedback through the chat. And my colleague, Ruth Nordstrom, is helping us behind the scenes from Adelaide. So, Craig, if you're ready, I'll stop sharing and you can jump in. Okay.
Sounds good. Thanks, Michael.
Okay.
Okay, I'll just get my screen share working. Can you guys see that okay? Is that coming up, Michael?
Yes, it is.
Excellent.
Thank you.
Okay. Oops, that's interesting. Just give me a second.
And that's Michael Koo.
my last
Van Koeverden's,
no,
not me, that you're referring to. That's fine.
Yeah. There we go. Sorry, wrong Michael. Okay. As you said, this is looking at the public comment draft for Section F for BCA 2025. I'll do a very quick introduction. Then we'll hand over to Ross Taylor, who'll give us some context on the how and the why we've got to this point with it, and describe the problem that we're trying to solve, I suppose, and then look at the performance clauses and the proposal for 2025. I'll then go through the deemed to satisfy clauses and put up some sketches and things like that that show what we think that actually ends up looking like. And then I'll hand over to Michael, who'll look at the engineering component of it, because as you'll see from Ross's presentation to begin with, it's something which is very much a holistic approach, which is needed to try and solve the waterproofing problems that we've been having. And it starts with the structure. It doesn't start with a thin black liner membrane, it starts with the structure. So Michael will talk to you about that. Myself and Ross and Michael have been on this journey for about 3 or 4 years now, starting with the Watershedding Community of Practice that the Building Commission New South Wales put together, which Ross chairs. And then that's then been parachuted into the Technical Reference Group for the BCA Section F. So we've been kind of intrinsically involved in producing the public comment draft that we've got here. There's still some words and things that we think have to be maybe tidied up in some clarity, so a few bits and pieces of it, but generally we were pretty ecstatic that they ended up taking on board all the things that we were trying to suggest that they should be doing. It takes a long time and a lot of effort to change anything in the BCA, even just words. So to get this amount of change into it this quickly has been pretty phenomenal. So with that, I'll hand over to Ross Taylor, and he can give you the context of what we're talking about.
Okay, thank you. Just a moment. So we go to share screen. Yep. Share. And now we go to there. How's that look?
Looks good, Ross. Looks good.
Yep. Okay. All right. So a little bit of background to the background. As far as we know, this is one of the rare times in which we've had an architect, an engineer, and an expert who normally sues architects for a living in the room at the same time cooperating. But he might appreciate that. Yeah. What we've essentially tried to do is to say, why don't we put the combined knowledge of those experiences together to address the complex issue of how water gets into the wrong spots of buildings so commonly and so repeatedly through our industry. That was the origins of the Watershedding community of practice for the Building Commission. Now, what we're showing you today then is here's the background to the proposed changes, the reason why, and then the other guys will show the detail of how. Yeah. 3 key points to take away today. Firstly, is that none of what we're talking about and other provisions are actually new to the building industry. They're new to the BCA, or to the NCC as a whole, but they're not new to the building industry. So we've got time-proven strategies at the basis of it. Point 2 is what we're doing, like the missing link of having the architect, structural engineer, and remedial expert in the one room, is we're connecting concrete, gravity, and drainage from what we can see for the first time in the NCC. And then we'll give you the lowdown on the key performance clause, the operative clause, and then Craig will take over on the deemed to satisfy and how to execute. So to begin with, time-proven strategies. We thought, how can you argue with the Romans and what they gave us? What did the Romans give us? Well, they gave us concrete, although there is some thought that, in fact, the Romans pinched it off the Greeks, who pinched it off the Turks, who pinched it off the Phoenicians. But we won't go there. But I think we could all agree that, especially addressing a group of architects, we can start off with the Pantheon in Rome. We're in safe ground here. It remains the biggest unreinforced concrete dome in the world, 43 metres wide, a lovely oculus at the top. And of course, this arrangement has been pinched by lots of people ever since, including our own War Memorial in Hyde Park in Sydney, and also the new War Memorial in Canberra, in terms of oculus, not in terms of diameter. This is nearly 2,000 years old. It's holding up well. Unless a developer gets permission to redevelop it, it should last another 2,000 years. Of course, it's based on writings that Vitruvius was, of course, you architects are all familiar with this. You've studied it endlessly. But we're going to have a slightly different spin on how Vitruvius has influenced the BCA changes. He, of course, is pointing in this diagram across to a Greek temple. He pinched the ideas off Greece and said, here's some good ideas, let's put it in a book. And that's all we're doing here, is saying, here's some good ideas from Vitruvius, let's put it in the book. Yeah. So for those of you that maybe it was a few years since you went to university, but you'll know that chapter 1 is about floors, and it starts with concrete flooring. For those that are less familiar with the book, down in the bottom right-hand corner, do I show? No, I haven't got a buzzer. Is there a highlighter? But what he basically says is that when you're laying a floor, then you'll cut falls 2 digits each way and let it have an inclination of 2 digits for every 10 feet. You can see in the top left-hand corner, which is roughly equates to 1 in 80. It's 1 in 79. And we pinched that. We thought we wouldn't use 1 in 79 for the NCC. We will use 1 in 80. He then goes on in number 7 there as to how to put a membrane on the top of that. So it's all about getting the falls below the membrane, not on top of it, which is so commonly the case. And of course, like many of you, you would have heard a builder say, no, I can't get 1 in 80 falls, it's too hard. We just highlight that Romans were able to get 1 in 3,000 falls for the aqueducts. So we skip forward a few centuries, and this is an actual structural engineer's drawing from the 1980s. It's showing a 100 mil step down to a balcony, and then falls to integral hob on the outside edge of a balcony. So for every structural engineer that says, no, we can't draw sloping lines, we can only draw straight lines, we say, yes, well, this was done by hand, but we need to bring that back to the industry. Similarly, what we're trying to really emphasize is what are the 2 things that have worked well in managing water on the outsides of the building? Well, one of them is a brick veneer wall, first emerged in the 1930s. It's been a very successful system, and it's based on the fundamental concept of drainage system thinking rather than perfect barrier thinking, which is about just putting a plastic bag on the outside of the building. Many of you will be familiar with the terrible problems they had in Canada and also New Zealand, and that was with trapping moisture inside structure rather than allowing the water in, capturing it, redirecting it, and draining it. So a screen, a cavity, a drainage plane works well in the vertical. Fundamental concept here is we're saying it works so well in high rise. Where has it gone wrong that we have so many of the flat bits that don't work? So fundamentally, the physics of water and gravity have been understood for millennia. But then it was lost for the flat bits. In my remedial work, constantly we come back to major university buildings, not just blocks of flats in the outer western suburbs or something, but major university buildings is where the verticals are okay, but all the flat bits, the podiums, the balconies and so forth, and the basements leak. So the facade drain system thinking has worked exceptionally well across the industry. So, background to why the changes have been put in place, we first have to analyse what the problem is. Well, how about this for a problem? The water-related defect bill has been assessed by S.L. Allen, economists, as being $4 billion annual expenditure. Now, some would say that that's how much was spent on lawyers, but I don't think that's true. It's also spent on an awful lot of jackhammering up of tiles and pavements and so forth across Australia. But one of the things from my experience in, well, 30 or 40 years in this, is that 90% of these leaks are from what we could call subsurface water. After the water seeps into the substrate, does its little tricks, runs along, comes out somewhere further along. That's what we would refer to as subsurface water, as opposed to water that just runs along in view on the top of the surface. This is where we see the pain occurring in so many units. The water that seeps into the structure can't get out, drains in drains in instead of draining away. This is the familiar pattern. Blue board on the right-hand side there. Michael, do we have a highlighter that we could use? I wonder. There's the device. Anyway, maybe we can't.
I don't know if I can. Ruth, can we do that, do you think?
I can't see that on the screen. But
I don't have anything on my screen.
Yeah.
With the blue, we've got water coming in through the blue board because it can't get out. Blue board's supposed to be a drainage system, but so often we block it. And then we have a flat slab We have membrane turning up to the outlet, and that is because of the disassociation in our industry of the shape of the concrete, where the membrane's placed, and the final finishes on the balcony. So we go from this situation, which works, which is the water being able to drain clearly and freely to the outlet, to the previous situation where it's all jammed, and we have basically a permanent swimming pool holding the water. Now, it's not just cheap and nasty building of, suburban builder. The same concept has caused leaks at Sydney Opera House forecourt for the last 30 years. Now, the main building, of course, has got good falls on it. That doesn't have a problem there. But all the flat bits have caused this. So many of you that have spent a few hours down at the bar down here would have recognised this in the ceiling. And of course, it's been repaired twice with the same old paradigm of let's hold the water forever because we've got a 20-year warranty on the membrane, we'll be okay. The thin black line, as we call it. But in fact, in this whole forecourt area, when we did the forensic analysis of the cause, we found that the only drainage there was for that entire area is that linear drain on the left-hand side there. There's any water getting down through the pavement underneath can't get out. So it has to be stored by membrane forever. And that's what that gives rise to this. Stored water down through multiple layers, and it's got plenty of time to cause mischief. That's when we have gravity working against us rather than for us. And of course, every highway we go down, we see efflorescence where subsurface water is draining through, shaking minerals and causing damage. So, as part of the team, the Watershedding Community of Practice team, of which Craig and Michael are members, we then had a look at the analysis of why it happens. And this is where we found this missing link, concrete, gravity, and drainage. This is an actual roof that actually the first one that was looked at by the Building Commission that I did in conjunction with Mr. Chandler and Matt Press. And this is a development, by the way, the developer is having an extended leave overseas, and the authorities are very interested in finding out where he's holidaying at present. This is the roof. This is an example of subsurface water, the water that would be under tiles and topping screed or pebbles or something. This is so commonly what we see is lack of falls in the finished product. In this case, that's a liquid membrane that's been put on, supposed to last forever, but of course, that's not the case. And when we go to the drawings to see how it occurred, we see this is the architectural drawing for it. Does that look familiar? They've actually built it the same as the architectural drawing, and it is flat. Now it's got an arrow calling fall, but the question is, where do you get the fall from? Where do you get the concrete from to do it? We'll look to the structural engineer's drawing, but no, there's nothing there either. So where do you get the concrete from to make the fall? Well, flat is quicker, they think, so it just gets poured flat, and somehow, somewhere, the water's got to drain away or evaporate. Then, of course, as Michael's going to show in a few minutes, in 10 years' time, you then have hogging and sagging of the balcony. And what we commonly find is we come back to these buildings and find that, in fact, when we come here, we find that the outlets are often at the highest point of the roof because the downpipes have been put in a column and it's been deflection away from the column. So this is the why. This is a shot of the architectural for that shot we saw a little bit earlier. And you can see here the description is about waterproof membrane is just the thin black line put on the drawing, and it says, it's kind of wishful thinking. What it really says, and this is not just the people in this room, it's right across the industry, it says, look, I know waterproofing is a point of litigation. There's a lot of leaks. Surely it's somebody else's problem. I'll just put it on the drawing. It's somebody else's problem. I won't actually try and integrate it into my design. So now it's slope tiles to floor waste. And that's what we end up with. That's the actual drawing for that roof, this roof. In other words, the water can't get away. And even worse, the outlets and downpipes and branches are an afterthought. This is quite a famous and substantial plaza in the city, and the branch lines were poured on top of the concrete, which was flat and stored water. Or even this beautiful photo from Nat Press of an inspection by the Commission where downpipes, when they're put in and thought about at the last, well, they have to work in around the rest of the structure. So this is what we end up with commonly across the industry. I have seen thousands of balconies that end up with this type of situation. So it may look like a cartoon, but unfortunately it's painfully real. I've seen balconies 2 years old with 140 millimeters of sagging, deflection. PT cracking, pulling the guts out of the slab. Separate hob on the outside where water leaches through, water running away from the outlet, and the thin black line, or the red line in this case of membrane, turning up, and everybody hoping that their 20-year warranty that they invested in is going to do the job. A flat slab right through, and water leaking in through under the sliding door. That just happens commonly throughout Australia. So, one of the other reasons why it happens is that the BCA between 1988 and 2022, by the way, was when we got first changes to the BCA, and a lot of them were changes from the Watershedding Community of Practice, the first tranche of changes. But between 88 to 22, there was almost no change. And Part F1, actually, this is the 2022 version, actually only referred to surface water management, rising damp and external waterproofing. And in this section on external waterproofing, because surface water refers to water landing on the site, when we looked at the definition of site and surface water, we then find that site is not the actual building. So in other words, the whole of the first section, Part F1 of the BCA, doesn't cover any of the building above ground. Then it had an exclusion for Class 7 buildings, which is car parks and so forth below ground. So in many Class 2 buildings, which are car parks down below, this whole section of the BCA didn't cover any of the building above the ground and none of the building below the ground. And we thought this wasn't helpful because the leaks are not happening at ground level. So what we've done is to merge Part F1 and F3 back where they were previously is a first major change. Secondly, what we've done is we saw that lawyers, and being an expert that sued architects and builders for a living for 20 years, we saw that lawyers love to get the expert to find a little gap or a loophole or something. And one of those is it's not surface water, it's rising damp. But it's rainwater, not surface water. So what we decided to do, we came up with the crazy notion of calling water, water. So instead of just surface water resulting from storm, that we would actually go to, let's see. Now it seems to have, we've lost that page. So what we've done is to redefine water as including surface water, subsurface water, rainwater, stormwater, rising damp is just now called water. Okay, so we don't have that exclusion problem. Now, similarly, we had the problem previously that roof and wall cladding said that it wants to stop water entering the building. Yeah. Now, down here in the objective, you can see safeguard occupants from damage caused by ingress of water from outside the building. And in fact, the old performance clause had a roof and external wall must prevent the penetration of water. Now that's completely counter to the idea of drain system thinking, which is allow the water in through the element, the bulk of it being deflected off the face, but some of it will come in because it's too hard to keep it all out in one go. But when it comes in, we then collect it and then we redirect it out of danger. So the performance clause here is the very opposite of what has worked best in the building industry. That is, drain system thinking for facades, cavity walls, for example, and pavers on support pads, which Mirvac have been using for 30 years successfully. Technically, because the building is defined as the outer element, you might not know it, but cavity brick wall or brick veneer wall has been non-compliant to the BCA for the last 30 or 40 years. And you should have had a performance clause for the use of it. You might be interested to know. So our committee's been looking very carefully at what the words say and what they mean. And if they don't mean what they say, then we change it. And that's why there's been such substantial change. See, at the moment, it refers to, and I think, and Craig's going to go over this in more detail in terms of the deemed to satisfy clauses, but what it makes reference across to is the use of membranes is the only reference to how to manage water, except for stormwater, obviously. But the average liquid membrane, if you get a 10-year warranty, you've got to recoat it every 5 years. And yet, as Michael's going to explain in a moment, in AS 3600, in concrete structures, they've got to have a design life of 50 years with 100 years for monumental structures. So that's the huge anomaly in our industry. We put a 5-year membrane down in concrete that's supposed to design life for 50 years, and as the Romans have shown us, can last 2,000 years. That's the huge disconnect. So now we need to bring back the connection of using the shape of the concrete in the horizontal or the flat bits to behave more like a drain system thinking. And that gets us to point 3. The fundamental watershedding performance clause that we have introduced is that of collecting, redirecting, and draining water as a way of overcoming the problems. So now, F1, P1, there's been a merger of 2 sections. We've left, we aren't touching the wet areas at the moment. That's for another day. And it's now referred to as managing water impact on the building and adjoining properties. So this clause on surface water is taken out and replaced instead with water collected or concentrated by a building. So that's collection. Associated site work or the allotment must be redirected, so there's the redirected phase, to a drain system, the drainage phase, to prevent bad things. Water must be collected, redirected, and drained. And here we have the definition. Water includes all of those things, so there's no arguing. Now, I can't tell you how much battle we had to actually get across the idea of calling water, water. So one key point I want to emphasize is the changes that are proposed here are just the beginning of shifting the way of looking at the whole issue of waterproofing and moving to a concept of watershedding, where there's the integration of all of the elements that are impacted by water to be an integrated design that manages the water flow rather than storing it or just having a membrane with a 20-year warranty as the protection. That is where you guys come in. Architects are being put forward to be the coordinator of these things. They don't have to be the expert in each aspect, but their designs are to incorporate all of these elements, not least of which is how the structure behaves. And Michael will go into more detail. And for the first time, we're now linking in Part B, under individual actions, included in it is construction activity actions include expected 10-year deflection for the structural substrate in Part F1. So once again, the architect doesn't have to be the expert on each of these aspects, but like we included in the design and building practitioner regulations, the architect must bring this forward and put it on the drawing so that all of the other players that are in helping to manage water are aware of the deflections, like you're required to have the 10-year expected movement in the movement joints. This now has to be taken into account. So what we're trying to encourage is structural engineers to now see themselves not as, oh, well, waterproofing is done by the membrane, but to have the structural engineer as being the lead waterproofer, if you like, which scares the hell out of them. But if you like, they're the lead watershedder. Their shaping of the concrete, the provision for deflection, the provision for movement is essential to the rest of the team integrating their ideas onto the drawing drawn by the architect. So that's it in essence. I'll just emphasize that for further detail, there are 2 courses that look at this new paradigm of how to manage water. One is on the Construct New South Wales, or they're both on the Construct New South Wales digital learning platform. One is called Waterproofing Design Principles. The other is Watershedding Design Principles for Below Ground, because we now have the exclusion of Class 7 car parks, or the lack of, or the ambiguity about that in the BCA has been removed. We've now taken that away, so now basements, car parks, such structures have the same level of importance as the structure above the ground. So there's 2 courses we'd highly recommend that you tackle and digest. They're both about 2.5 hours long. So that's it in essence. I think we're up to time. So I'll hand back over to you, Michael.
Thank you, Ross. Can I remind everybody, if you'd like to interact with us, please do so in the chat, and we encourage you to fill in the Google form. All the details are in the Zoom chat, and we will also be posting this as a video on the Institute's YouTube channel, and we'll let you know when that's up and running. So that'll be good for anybody else who didn't get to see it, or if you want to go back and have a quick review. Craig, are you going to have another few words?
Yep, my turn.
Thank you.
Can you guys see my screen okay?
Yes.
Excellent. Is the text big enough for everyone to read?
Yes.
Okay. Okay, so I'll look through the deemed to satisfy clauses and give you some sketches and things of how we think this plays out from a design perspective. This is really what we're aiming towards. This is kind of the outcome that the whole thing is aiming to get, is a balcony which looks remarkably like the sketches that Ross produced there. I'm not going to go through it all in detail just now, but really we'll build up parts of it by looking through the clauses. If we start, F1D2, F1D3, minor changes just to numbering and things because all the numbering's changed again. Nothing to the stormwater drainage thing, and the real meat starts to happen at F1D4. So basically it's saying that you have to have a minimum 1 in 80 falls in the concrete in your balcony, your roof, whatever, podiums, but typically we're mostly looking at balconies as the main one that causes most of the problems for these things at the moment. But anyway, so 1 in 80 falls in the concrete, and that's in the concrete, not on the tiles on top, but in the concrete. I think we need to advise that there's some words have to be put in there to say that that's in the plane of the floor, similar to what's in the internal wet areas part of it at the moment, because there's a huge level of confusion about where you actually measure a fall on a floor. The next part is that there's a 70mm step down in the concrete at the balcony edge. So going from inside to outside, the 70mm step down. And again, that's in the concrete. We think that they have to change the wording to say that that's from the structural slab level and have a definition for what SSL is in there as well. But certainly that's the intent, is that it's a 70mm step down in the concrete. Next part is there's also a 70mm integral hob at the outside edge of the balcony. So, not where there's an external wall sitting on it, but at the outside edge. Again, I don't think the wording in that is particularly good. It ultimately says what it has to say, but I think it's poorly worded. But as I say, but if you think through to Ross, Michael, and I, and a number of others who sit on the technical committee, while we're very heavily involved in pushing the ideas for this, every time we write something, then it goes away into a dark room with lawyers and other people who try to make it into the most confusing language they possibly can. So we're never always happy with some of the language that comes out of the wording, but the principles are good. Key thing down the bottom there, falls can't be done in screed or tile beds or things if you want to do a deemed to satisfy solution. So putting a flat slab with a membrane, with a screed, with some tiles to a fall isn't going to work anymore. So again, that's why the concrete ends up looking like this. You've got an internal structural slab level, a 70mm step down in it. You've got falls at 180 in the concrete to an outlet. You've considered the outlet, the level of the outlet, the overflow levels on the outside of the balcony, the hob that's out there as well. You do this in conjunction with your hydraulic engineer. You work out what all those levels are, because they're all quite critical. You make sure you can get the drainage pipes cast into the concrete back to wherever the column is or wherever that you want to try and take them down, and think about how the deflections work. Think about how the engineer can help you try and either stiffen things or tell you exactly where deflections are likely to be so that you can place outlets accordingly. One of the key things in the design of this is that if you divorce the drainage plane, which is here with a membrane sitting on it, from the plane that you walk on, potentially with pavers on pedestals and things, then the location of the outlet isn't really a critical thing anymore. You just put it wherever you can get the falls to work, because you won't see it. It doesn't line up with anything. You don't get strange angles and things in your final surface finish. So it becomes a bit easier to do. One of the other key things here is also looking at the floor to floor height. You can get this to work in a pretty comfortable way with a 3200 floor to floor height. If you start going below that, you need to be telling your clients that it's going to take significantly more coordination to try and get that to work. It can be done less than 3200. We've got some down at 3100, which can be made to work. But again, the amount of coordination involved in it is exponential. So pushing everywhere you can to try and get residential floor to floor heights at least 3200.
Craig, can we just emphasize, please, mate, that the origin of those sketches and that they're not in they're not going to be in.
Yes, good point.
Can you just emphasize how?
Yeah. So these sketches are sketches which have been put together by the Watershedding community of practice. Excuse me, we were working on these sketches actually before we got incorporated into working in the BCA, but the BCA effectively reflects what's in these sketches, but the sketches themselves won't be incorporated in the BCA. We're going through various negotiations. There was a discussion about whether they become part of a Standards Australia technical specification, which has pros and cons. And, some people online, you will have heard me rant about Standards Australia and the inability to access standards in a reasonable way. Means that we might be moving away from that. There's a possibility that it may become an ABCB handbook, which will be more generally available. So, but the idea is that we're trying to get as much knowledge out of how you can do these things, how you can get good outcomes with as simple in as simple a manner as possible. It's demystifying the language around it and trying to get it into drawings that everybody can understand, recognizing the fact that not everybody is a certifier, not everybody's an architect, not everyone's a hydraulic consultant. A lot of the people that are actually needing to know this stuff are people on site who don't necessarily use English as the first language and things. So we're trying to make it as simple as we can through that process. So you'll see these sketches hopefully start to come out in a good form. The big thing that we're really hoping to do is start getting something which makes them mandatory rather than just here's a suggestion. And we have some mechanisms that we're developing to try and hopefully get that to start happening as well. Anything else you want to add, Ross?
No, I think it's just a case of I think it'd be important to add that AIE is a critical role here, is that we are seeing the BCA and the standards and the language that it's used has been confusing, and you need experts and lawyers to read it. And we're trying to shift the way of communicating complexity. And the diagram, Craig's diagram on the screen, is one way of communicating complexity, as you'll see. That's the next phase of the community of practices
sections.
Thank you.
Yep. We go to F1D5s, looking at substrate materials. This is saying balconies, podiums, and roofs have to have a structural substrate of concrete or FC sheet. So you can't have balconies which have got chipboard or ply or whatever and are deemed to satisfy solution. Part 2, they're saying the concrete has to be good enough to take the membrane, basically, which you would think sounds fairly obvious, but that's not always the case. It's frequently not the case. In fact, when the membrane supplier and installer turns up to do something and the concrete's rubbish and they get told, well, do it, or, you know, we'll get somebody else to do it. F1D6, looking at exposed joints. Sections A and B have been added in there, which are basically saying that any joints and slabs which are exposed to water one way or another should be at the ridge line or a high point, which, you know, makes a certain amount of common sense. Joints are always the weakest part of any building which is trying to keep water out. Joints are where it always comes in. Other things as well, you get cracking and all sorts of stuff, which Mike can go into, but really you've got to try and get joints in a reasonable position to begin with, so you stand a chance of keeping the water out. Joints like this, we're saying, should have a hob poured integral with a slab, 50 mil for the length of those joints. So again, you've got a reasonable chance of keeping that subsurface water from just going straight through the joint, because joints relying, again, purely on membranes and sealants are doomed to failure. Otherwise, anything below that, nothing really important happening. There's just some stuff moved around, but no substantive changes. F1D7 is looking at membranes. So basically saying in a concrete roof, the membrane must be applied to the concrete, not to a screed, not to topping, not to anything else. It's got to go onto the concrete. So your concrete's at a fall, the membrane's on the concrete, and it's going to a drain. So again, looks like this. It's the shape that we had come up with before, but now your membrane is going on that. Excuse me, it's all fairly straightforward stuff. I don't think there's anything particularly contentious there, other than the fact that for years and years, people have been doing screeds to get the fall and then membranes on that, and then wondering why the water keeps coming into the building, because you're putting the membrane in an incredibly vulnerable situation where the substrate that it's on is going to crack. And then once it goes through there, the water's going to set in something that doesn't have any fall in it. F1D8, F1, put the one after that, I think that was 10. Anyway, damp proofing requirements now apply to Class 7 and Class 8 buildings, which there was always an exemption for before. So that, most notably in a lot of the cases when we're dealing with multi-res, is looking at basement car parks. Also covers warehouses, factories, and laboratories, which surprisingly didn't have any requirement for any of this stuff before. But basement car parks are now starting to be treated as a significant part of the building which you have to protect, and particularly in multi-residential buildings. The basement car park is actually your front door. That's where most people end up arriving at these things. And a lot of cases, we still treat them badly. They're also an extension of your apartment, because most people now have storage and cages down in basements and car parks, where if you're storing a bunch of your books and things in a cardboard box down in the steel cage in a damp environment down there, and then you bring it back up into your house, you're just bringing mold in with you. And you spent lots of time and effort trying to make sure that your apartment is clean and dry and mold free. No condensation issues and all that kind of stuff, but now you're just bringing mold in because it was all sitting down in your basement anyway. F1D10 is looking at surface finishes. So saying that balconies should have self-draining floor finishes. So that basically means things like pavers on pedestals, timber decking or whatever, but it's something which allows the water that's hitting the surface that you're walking on to drain through that into a drainage plane down below. So it's that collect, redirect and drain thing that we keep putting together in drain system thinking. Tiles can be direct fixed to a membrane on the slab, as long as, again, that concrete is prepared really well. And again, that can be done. Ross has got good examples where people have been able to do the concrete beautifully and it works well. But, excuse me, the key thing is that you don't get tiles on crappy, drummy screed anymore. The limitation there is that that doesn't apply to areas which are subject to vehicular traffic. So something where you're going to have a problem with, you know, the loads on it, potentially either breaking pavers or being too heavy for pedestals to deal with. But again, pedestals can take pretty serious weights. We think that the I think the wording there could be improved. I mean, include in something which says where a surface finish is applied above a membrane, it doesn't apply because there's areas with vehicular traffic, because it sounds almost there like in those situations that none of it applies. So I think there's some tightening of the words that they could do there. And really, that ends up with the paving stuff on the top. Again, some things to bear in mind with the paving is looking at the structural adequacy of them, considering uplift in high wind locations, maintaining the minimum drainage gaps, coordinating with overflows so they don't block overflows. And also a key thing is keeping a 10 mil gap around the perimeter of it, which is, you know, again, our hydraulic engineers on the committee have been looking at making sure that water doesn't sheet over the top of that in high wind situations and simply go, you know, drive straight against your glazing systems and stuff. So that 10 mil gap effectively allows that to drain well as well. F1D11 to F1D15. Previously, window and wall cladding didn't have to comply with the BCA in basements, car parks, factories, warehouses, laboratories. Again, that class 7 and class 8 thing. So the only change there is that that exemption has been taken out. So if you have, you know, in our case, it's more to do with basement stuff. We're looking at if there's glazed assemblies or wall claddings forming part of what you would consider to be a basement, then again, they still have to comply with the rest of the clauses, keeping water out, keeping weather control done. And other than that, there aren't any deemed to satisfy changes beyond that. So that's basically everything that's there. Just briefly, as part, again, the sketches that we're trying to produce in what might be a handbook, we've got some examples showing how those might work in reality. So this might be a situation where you, at your doors and windows, where the step down happens in the concrete at 70 mil, your finished floor is added above that. Excuse me. If you have a requirement from AS 4654 for your membrane termination height to be above 70 mil, so let's say you've got a 120 mil requirement for your membrane termination, then that could be a 50 millimeter angle placed on top of the concrete internally. But you wouldn't necessarily have to take the concrete up. It would be great to take the concrete up to 120, but sometimes that's pretty prohibitive. So that's one way of doing it. You can have another situation where you may end up putting your glazing system and stuff on top of the slab. Again, might depend on whether you need level thresholds going out, either DDA access or you just want a nice clean level threshold. Then again, you probably want to drop it down. And other versions which look at putting a double rebate in there, which is my personal favorite. I think it's the best of all worlds, but recognizing in a lot of situations it's not always the easiest thing to form for the concreters. Then kind of elaborating in Ross's sketches earlier, what happens when you have walls meeting this thing is that you're basically taking a continuation of the drained system thinking, you collect redirecting drain things that things like cavity walls and rain screen cladding systems have, and carrying that through into the floor as well. So everything falls from one thing onto another, onto another, onto another, and drains out appropriately. And that's really what the whole thing ends up looking like again when you put it all together. So that's pretty much all I've got. Just a reminder, if I know Ross mentioned them earlier, the two training courses which are on the Construct New South Wales website, one for general waterproofing principles and one for below ground structures. They're the most valuable, useful bits of CPD I've done in as long as I can remember. They're really, really good, and I'd strongly recommend anybody who's interested in waterproofing or having to deal with this, go and look at those, and it really explains a lot about the principles behind what we're talking about today. Yeah, and that's me done. I'll hand over to Michael Van Koeverden.
Craig,
Yep.
Before we go on, we've had a few questions directed to you.
Yes.
from Kirby in the chat. Kirby, you've been busy. You can probably see them if you go into the chat yourself, Craig. But I mean, I'll read the first one out from Kirby.
Yep.
So, Craig, 70 millimeter step down to balcony FSL would be greater to allow for applied balcony finishes, if I'm hearing you correctly.
I'm sorry, could you say that again, Michael? Sorry.
It's 70 millimeter step down to balcony FSL would be greater to allow for applied balcony finishes, if he's hearing you correctly.
Yeah.
So, sorry, Craig. Hello. How are you?
Oh, hey,
I don't know if you can hear me.
Yes, I can. Yes, can you hear me?
Might just circumvent it. I guess when I look at your diagram and when I look at these adjustments, I'm interpreting that the set down is to the actual finished slab level, and then we've got a build up above. So I might end out, if I want level thresholds, I might end out with, say, 120 mil. Who knows? That's what we're something like that. But what we're saying is no screeds anymore. And tell me if I'm interpreting wrong, but no screeds, everything goes on the integral falls. And we're building up from that. So what happens in a refurbished, and look, you may not be able to answer this, but are we saying now that if I'm working in an existing context where there's not enough integral falls, what do I do? Do I do performance solutions, or what's the NCC asking me to do?
It's an interesting one, and this was a large part of the conversation at the conference that we were at on Friday, dealing with this issue with a lot of remedial builders there talking about it. There's a number of answers to it. One is, yes, the performance solution option is always there. The real answer to that one is for people like Accra who've started doing this, I must admit, to start doing some serious lobbying of the ABCB to try and figure out how they're going to basically start dealing with remedial situations. One of the decisions that we made very early on in the piece was that we're not going to water down how we build new buildings in order to make it easy to keep bad old buildings. What we'd like to do is get to the stage where, remedial works in buildings become less and less of a requirement. We'd like to see that chunk of the industry start to shrink. It's going to be there for a long time. There's so many problems and so many existing buildings that it's going to be a large chunk of what we're doing for years to come. But we'd like to stop baking those kind of problems into new buildings. But in the meantime,
Craig, could I have
a solution for a problem, or a possible solution? Yeah, I know Ross has got some views on this one. If you want to jump in, Ross.
Yeah, just to what the short answer in terms of remedial is that there's been a slavish, by the lawyers, a reaction to deem dissatisfied anything else as a performance solution. In fact, what we're working with Accra is to show them that, firstly, BCA and the NCC as a whole is a new building book, not a remedial building book. That's for starters.
No, that's
secondly,
nice, different, I guess, to the views of the certifier, right? It's
the important factor here is that when you then come to a building, it's obviously not demolishing the building so that you get integral falls. Yeah, because as I pointed out there, at the moment, a brick veneer wall doesn't do a performance solution. Interestingly, you might like to know that tiled floor bathrooms doesn't comply to the current deemed to satisfy all performance requirements in bathrooms anywhere. And you've never been asked to do a performance solution there. The point is that there's pathway in our system for being able to use acknowledged or accepted building practice. So one of the things that we've said to the remedial industry, they just have to develop a remedial code that shows how you use engineered screed on a concrete slab to give it falls. And under the new regime performance clause, all they've got to show is that they are collecting, redirecting, and draining the water and not storing it. That's where the two documents come together, but also not just a slavish use of 4654, for example, or just in terms of, we don't have any. I had somebody the other day, a remedial person, say, when this comes in, our remedial industry is over. That's how of using the slide literally, rather than seeing that it's just one way of achieving the end objective.
Yeah, it's interesting, Ross, because and I say this because I'm working on a lot of projects at the moment that I wouldn't call them remedial. They're, we're stripping. It's actually, I guess, people trying to deal with cost of construction, cost of new building structures, and obviously carbon and all of these other sustainability goals we're trying to embrace. So people stripping out buildings and then looking to refurbish them. And obviously you've got design life questions around existing structures and all these. So if we park those up, you've got balconies as an example like this. And so I love the thinking that, you know, these sort of existing circumstances are very different to a new building. The problems that I'm seeing are that obviously certifiers are very reticent to, you know, sign things off, as we've seen the blowback of that. So it's going to be really interesting to see when this does come through. And obviously, this is a great presentation, how we can socialize it with the certifiers so that they understand the difference between what's a new building and what's an existing circumstance, and how we can all meet in the middle.
Can I just put this to you too, and this is one to throw just a personal challenge to you, since you've raised the question, is I'd like you to reread the NCC Volume 1 and have a look at the other pathway, which is a deemed to satisfy solution.
Okay. Sorry, Ross, are you going to be brief?
Yeah, then we better move on.
Because I'd like Michael to have his chance to speak as well, and then we'll come back and finish up the Q&A.
Come on. Yes, Michael, let's go.
Okay, thank you. Michael. Excellent. Thank you, everyone, for those comments. That was really good dialogue. Hopefully you can see my screen okay. Craig, can you see that okay? Hopefully.
Yes, we can.
Getting there? Yes.
Yes, you can. Okay, excellent. Thank you for that. So apologies, I've got 3 screens running, so I'm looking to the side, but I'm really wanting to look to you. It's a setup with my camera, so if you can look past that, we're all happy. So I want to talk about the engineer's role in preventing leaks in buildings. And Ross talked a little bit about it before, and there's a big difference that we have to recognise that membranes for a long time have been seen as a waterproofing or a way of waterproofing buildings. And the structural engineer's job has been to make sure the loads are transferred through the structure to the ground to meet a certain design life. So because there's a disconnect there, we expect the membranes to fail. And what happens, of course, we've just talked about today, when that occurs, the building needs to drain. It's pretty simple. So as it says there, 10 to 15 years for membranes, but 50 plus or minus 20% for the structure itself. So there is a disconnect. So at some point in the life of the structure, the membranes will either have to be repaired or there's going to be some sort of refurbishment to deal with this water. So that has to be built into the design going forward as well, is the fact that we may need to maintain this over time. That's where what we'll talk about is quite beneficial, because it is easier to maintain when you have pedestals and pads. So one of the issues is deflection, and this is just a photograph of when I'll go to the chiropractor. I just walk around the back of the street and there's this house I always see, and every time I see it, I look at the tip of this cantilever deflecting on the right there. So we've got obviously deflection with time, and the cantilever itself will try and move, of course, under gravity and other things, wind load, etc. So we recognise that there's a deflection that we have to measure. The reason we chose 10 years was because you can see a lot of the deflection is taken up in that period. So if we made it further into 20 years, the net gain is less. So 10 years deflection gives you a pretty good understanding of how the building is going to move, and that helps us as design engineers to determine how stiff we make the structure. Obviously, stiffness attracts load, something we're taught at university. So it's a matter of making sure we understand what the building is going to do over time and how we respond to that for the loading. The other one is creep, which is a reduction in stiffness. So as the building gets older under the action of gravity, obviously gravity is trying to pull it to the center of the earth. So you get these structures that do respond very poorly to creep. And Ross's point earlier is really valid of thin, flat slabs. Some people believe are cheap. And what happens with those, they're very susceptible to movement. So we need to start to think about how we design our buildings so they're not moving around too much and causing us issues. I just stole this heat map off Ross, but it's a good indicator of what structural engineers will need to do in the future, is to give predictions in 10 years of how their buildings will move. Now, that's really important, because that dictates where the drainage outlets need to be. We've got 1 in 80 falls, but we want 1 in 80 falls for a long period of time, not just for the first 10 years. So we need to understand that there's a recognition of the structure to perform a primary role of waterproofing. As Ross said earlier, collection, redirection, and drainage. And it's very much about the structure playing, doing the heavy lifting in that relationship. So one of the things I raised, and Craig raised it before, it's important for architects and engineers to understand the proposed column layout, for example, in a building, to assist in the design and impact on drainage outlet layout. Because if we're putting all our outlets in columns, what's going to happen between the columns is it's going to want to try and deflect. So we have to recognise there needs to be a discussion up front between the engineer and architect to get a design that's compatible with the sort of hydraulic stuff I'll talk about in a moment as well. So between the columns, you get this deflection. So it's the most likely place for drainage outlets to be located, but it has to work in with the design intent from the architect and obviously the input from the hydraulic engineer for the water that has to be dealt with. This is Craig's drawing. I've repeated it here because I wanted to reflect on it as a system. It's an entire system. Sure, we traffic the pavers on support pads, but we really are relying on the structure to provide those integral falls. And I think that can't be understated. The fact that we need to recognise that we want good quality concrete, well placed, and I'll talk about that in a moment, that performs its function. So the membrane can fail, of which it will, and that will allow us then to still have a structure that drains, as Ross said, as the Romans did 2,000 plus years ago. I'll step into some detail now around some of that. So if you've got a flat slab and you put a topping on it, what actually happens is you get differences in shrinkage between the structure itself and whatever you put on top of that. There's also a difference in stiffness. So they're going to respond differently to load because there's stiffness attracts load. You'll get the structure taking more load than the topping. It can also induce curling. We get shrinkage forces. We get curling because of the thickness of the topping. And you get this wet, dry cycles that occur with concrete over time. So concrete will continue to shrink and swell for its entire life. It just becomes less and less, as you can see in the bottom drawing there. Hopefully you can see my mouse, but you can see it starts to taper off, but it'll still continue. So when you've got this differential, the topping is bound to fail over time, especially if the structure itself is also deflecting because it's flat. And it's simply because the topping has a difference in moisture top to bottom. Whether it's wetter on the bottom, if it's where it's wet, it wants to swell, where it's dry, it wants to shrink, you get a difference. And it can either be, upward curling or crowning where you can lose the surface quite easily. And again, I do a lot of legal work as well. I've had some legal cases on exactly this. So integral falls works better because you're getting a more controlled shrinkage profile through the section. So you're not having this differential, you've got controlled predictable shrinkage. You've got the same forces that are applying, but now you're dealing with it in a more holistic way. So it's a much better way to do what we want to do. And it ensures that this difference in moisture and stiffness and deflection is accounted for, at least with respect to the topping. The important thing Craig spoke about is floor heights, 3,200, having enough there to do what we need to do. The step is a set. I think one of the speakers, Kirby, I think spoke about that might be built up to 120, Craig. Well, in this case, 70 is a minimum. To give us, if you like, a catchment area, which I'll talk about later. Craig mentioned all these details, which I won't go into too much, but one of the big ones is the pipe location so that we understand not only just where it is, but what size it has to be to take away the water. So there's a really important aspect that I'll talk about in a moment. Here's a build-up of that. So a developer hopefully will allow you enough floor-to-floor height to get 3,200 mil. You'll have your minimum 70 set down. You'll have an overflow level, Craig, which will set the reservoir, if you like, or your catchment, your water catchment area. You'll have a pipe location, which has been developed between the architect and the engineer to work on the best case scenario. So as Ross said, the low points always are the areas for drainage. You don't have drainage outlets in the high points. We then have a 1 in 100 falls to the pipe to make sure the water can get away. And we have to size the pipe here to suit also the water that's above. I haven't drawn the pipe that comes from above, but you could be picking up units within a multi-unit facility. So the consideration needs to be done on the hydraulic engineer's component to that. So this is really important. And it's recognition, I think Ross has talked a lot about this in the past, about the design pyramid, with the architect on top, the design engineer, and potentially hydraulic engineers, then builder below. But the architect's design intent should be carried through the entire design. The concrete itself has some requirements, which we don't have time to go to in great detail, but for things like crack control, putting splays or reducing re-entrant corners is a big thing. In my practice, I deal a lot with this, is minimizing crack control, putting pencil rounds where you are on uppers and chamfers on edges. It does make a big difference. No joints in balconies. I'll talk in a moment about post-tensioning, but no pans in the balconies, because as the concrete moves and swells and shrinks and deflects, these pans can open up and leak, and you end up with effectively a point of leakage through the balcony itself. The big question then becomes, well, what's the design of the joints? Well, we want to have joints outside the balcony that if possible. Sometimes we can't, but if we have to, we want them outside the balcony. And we want to have crack control. The question then is, do we make it a tank slab where we have a water retaining structure, or do we allow for some movement through controlled joints? So as part of that is the unplanned stresses. I'll answer Kirby's question a bit later about if you've got an existing building and you want to retrofit, there are some things you can do. You can put control toppings on that will still help, but it's not a new and long-term solution. It's a solution, but it's not a long-term solution. So let's talk about that. You can do things like add fibers to it, which I've done a lot of, and we can get into that discussion in question time. So the question is, what level of crack control do we need to obtain? That's a design decision by the structural engineer, working with the architect to get the detailing right. So you might have post-tensioning, for example. We talked before about the live end in the unit, not in the balcony. And end stressing, I know, is not architecturally ideal, but obviously it is another way to get the pans out of the balcony. Things like cares, is a presentation I did recently for cares, is it really about understanding the way that your post-tensioning is being installed and the way that it's performing in practice. It's not just a line on a drawing, it actually has an implication on the structure. It can cause the structure to twist. I've had projects where one of the cores was a lockable core, and one was a temporary core that had to be locked. The order of the post-tensioning caused it to twist and induce large cracks in the slabs. So things like care certification assures that whoever's doing your PT is enacting your design appropriately. So I certainly recommend you looking at that as an architectural first point. There's obviously the 3 C's of concrete. Good cover, well compacted, and well cured is a really good starting point. Because now we're relying so heavily on the structure, we're recognising the role of the structure. We don't want unplanned cracks in there. And we can do that with good concrete practices. As Ross said, this has been done for 15 years with some builders like Mirvac, but other concrete has been doing it for 10 years plus in other buildings. So it's quite recognised that this is not difficult to do. It can be done quite simply. It's a matter of just designing it early, recognising the need for it to occur, and making sure it's delivered in the design and construction phases. So we've got a post-tension tendon. We've got what's called dead ends in the balcony, live ends in the dwelling, as I've said. We add an additional shrinkage steel. This is an active design for buildings in Sydney right now, where the post-tensioning is part of the design, but we add an additional layer of meshy for crack control, because this cover will get increased because of the falls. We don't want the reinforcement to be too deep in the section, because if a crack does occur, there's nothing to restrain the crack until it gets to embedded reinforcement. So the SL282 on slope gives you that crack control while maintaining cover. So that's really important, and that's something that I thought is worth mentioning to you. As Craig said, the membrane direct stick to the 1 in 80, so it should fall. And then we've got to also make sure we terminate that appropriately at other locations. And our pavers on support pads becomes the final part of the system. Ross, did you want to say something? We just bumped. Okay. So the membrane still has a role, and I see that this as a redundancy in design. As engineers, we like redundancy. So if the primary system doesn't work, we've got a secondary, we've got a tertiary. The primary system is the structure. Let's get that right. We've got the membrane as a secondary system. And if you like, the upper layer of pavers, as we said, will initially capture the water, slow the water down, and allow us to get better controls of what it's doing. So the pavers themselves have to be structurally adequate. So there is a design phase, and the work we're doing with the Watershedding Committee of Practice talks about some of the structural testing of those pavers. so that we understand that they'll be able to withstand the type of loading that people would put on them in balcony applications or other applications. And as Craig said, there's important things to deal with, like edges, at gaps at the edges and also in between, so people don't get their stiletto heels caught in there. But that's another discussion for another day. So in terms of what the rain will do, it'll follow that path that we've created. We've got redundancy in design. We've got a suitable platform, or we think a wearing course, if you like, that's also disabled access friendly, because we can adjust these pods over time to make sure we maintain that slope. We have an overflow built in, so we're not going to ever overflow the structure, the building, and we've sized our pipes appropriately through hydraulic design to make sure any water that's collected, redirected, is adequately drained and dealt with, and not spilling in other places. So the changes to the NCC from a structural point of view, in the performance solutions, in assessing structures, they've moved away from verification by expert judgment, which was an allowance that expert structural engineers could make on a particular solution. The intention is to, of the changes in volume 1 and 2, is to improve their robustness of performance solutions. The structural reliability verification methods for combined actions are now applied, not for individual actions. So again, this is provided to me by a practicing structural engineer who's also part of our Watershedding community of practice. And there's been the removal of expert judgment as an assessment method for structural components. So what that means is there's a recognition of a system that doesn't rely solely on the individual to make an expert opinion on the suitability. I think that's a good thing moving forward. So in 2022, the NCC was, from a structural perspective, was qualitative with respect to the structural provisions. The proposed 2025 changes are more quantitative, and they rely on setting requirements for components made of new and novel materials to form construction. And that encourages innovation, but also prevents practitioners from setting levels of public safety solely on their own discretion. So again, what this is meaning is there's a recognition of there's a bigger picture here. We've got a reliability that we need to build into the buildings by combined actions, by a more direct approach to the way we engage with buildings and the way that they've been constructed and built. So I've just put this, Craig, as a last slide, just to talk to obviously the changes are clear and they're on public record. So again, we all encourage you to give that feedback. It's really important to the try to work that we're trying to do. The way I'd like to close, Craig, is say I've never seen collaboration like this before at this level between the designer, the practitioner, the architect, the engineer, the waterproofer, in Ross's case, the hydraulic engineer, Ross, the builders. It's quite a unique position we find ourselves. And I think that's why these provisions have been so successful in getting into the NCC, because they're needed. You've got to remember, people live in these units. They spend their last dollar getting into these units. The cost should not be on them to pay for any rectification. So I guess that's where I'd like to leave it. Thank you.
Thank you, Michael. That was great, and I like what you said about that collaboration. That's really great to hear. Craig, have you got some remarks before we? We've got a couple of questions, and perhaps Kirby's got a few things extra she'd like to ask. But Craig, over to you.
Kirby and I can catch up for a coffee as well for anything that.
Yeah, that's totally fine.
Look, that's a terrific idea. Yeah.
You're welcome to join, Michael, if you want.
Oh, look, I'd love to. I'd love to learn a lot more about it. Yep. But
yeah, I think the only thing I'd say in closing was kind of what Michael was saying at the end there, that it's the process that it's gone through to get to this part is a product of integrated thinking. It's everybody in the design and construction team getting together. The community practice that we work in has got concrete placers, it's got form workers, it's got a whole series of different players, it's got suppliers of membranes, it's all QSs, it's got all of those things in it. And that's how we can get to what I think is a pretty robust solution to where we go to try and solve the problem, because don't underestimate how large a problem this is. Anybody who's listened to David Chandler or Matt Press in particular talk about defects in the building industry and confidence in what we're providing to consumers knows that this is a phenomenally large problem. As Ross showed in his slide, that economists who were looking at pricing the changes proposed for this before they could get into the public comment draft were saying that as far as they're concerned across Australia, this is a $4 billion problem. It's an outrageous problem for the construction industry that we're all part of to be presenting to the public. So it has to change. It's got to get better. I think improving it is better for everybody, both from the consumers at the end of the thing, and also for all of the people sitting in the room here, all the people in the community of practice that are working hard on this. It just gets better for everyone. One of the key things that's come up in conversations around this, particularly from a number of the builders who are involved in the community of practice, and those range from big tier ones down to much smaller builders, is that most of the ones who are sitting in there do this stuff anyway. This is how they construct buildings at the moment and have been doing for a while, because they know it works, and it means they don't come back afterwards again and again to try and rectify problems. What they would like is to get it into the big book so that everyone else has to do it as well, and there's a level playing field, because at the moment they feel that they're providing a premium, not a premium product, they're providing a product which works. It's simply something that works, but they're being undercut by people who can get away with what the BCA tells them they can get away with. And as Ross always uses a fabulous term, one I always love, which is that the BCA is the worst possible outcome you can get and still stay legal. It's not good. So satisfying the BCA isn't a good outcome. It's the worst outcome you can get and still be legal. So it's always a good one. I think I'm going to end on that one. I think that's my favourite bit to end on.
Thank you, Craig. We've got a few questions that are coming through now in the chat, so you guys can probably see that as well. But I'll read out a couple from sort of going back to Novati Constructions. Thank you very much. Will the increased addition of mesh for crack control inevitably require thicker slabs? And does this need to be fully considered at the very beginning when floor-to-floor heights are being set before a project goes for authority approval? Who'd like to answer that?
Do you want me to start with that one, Craig?
Yeah, go for it.
Yeah.
Okay, so we've got to recognise that the additional mesh is there for crack control. Its main purpose is for shrinkage crack control, and a lot of that is early age shrinkage. So concrete will shrink to its centre of mass, and it'll do that within the first short period of time, normally 12 to 48 hours, depending on the moisture conditions. So it's a crack control primarily. The structural function is performed by the post-tensioning, but because it's an SL82, it does have some stiffness, so that means you will get some benefit, an increase in stiffness. The reason it's added is because of the falls that are integral, because the integral falls, as I said in my presentation, may increase the cover. We still want the minimum cover at the lowest point, which means when we start to get the fall in place, we get additional concrete. The intention is of then bringing that up on the same plane as the fall, is to provide minimum cover while giving good crack control. As I said, if the cracks occur, they can then be restrained when they meet that SL82. So what the important thing I think here is, in responding to the question, is having the discussions early between the design engineer, the structural design engineer, hydraulic engineer, and architect, so that we make sure we understand, firstly, as I said earlier in my presentation, what's the best location for drainage outlets? How does that then fit with respect to the rest of the building? And how do we accommodate these falls back into the structure in an appropriate way so it drains without causing too many other issues to the performance? I don't know if that answered the question. I hope it did.
Okay, thanks, Michael. Another one for you from Nick Loader. Will thermal bridging blocks be integrated with the PT and shrinkage and other reinforcements?
Yeah, good question. The whole discussion around thermal threshold is an important one, Craig, and I'll throw to you in a minute if I can. We did raise this in the Watershedding Committee of Practice about how we'll deal with that thermal. A lot of it is to do with the detailing of the structure itself. So I don't know if you want to weigh into that, but my point with the post-tensioning is that there's got to be the discussion around not only the thermal but the fire protection aspects of the building as well. So I think I would go back and say that yes, you would need to consider the thermal conditions because of the changes in thickness, but I think there's more to it. Craig, can I throw it to you?
I'm and looking at that one, I'm presuming when you're talking about thermal bridging blocks, is this to do with thermal bridging from a thermal energy point of view, or is this a specific structural requirement that we're talking about? I'm not understanding.
If it's a structural one, it's to do with the changes in thickness, because concrete's exothermic, so it's going to give off heat. Right. So the thicker the section, the more it's going to be impacted by thermal effects. Anything over 500 millimeters, you need to do some thermal analysis, which I do.
I remember you talking about this in the community of practice. That's right.
Yeah, we were talking about this, but what we're talking about is it depends how thick the structure becomes, is when that triggers those requirements. Good structural design, understanding the way that the structure itself is going to perform will minimise any of those issues. But when I was saying thermal stuff, I was thinking more the threshold of the building inside to outside. That's why I was calling to you about. Thanks, Michael.
Greg, could I have a crack at that one? Is
Please.
just when we can, there's 2 points that come from. One is that when we had a look at this bridging from inside to outside heat in winter and the other way in summer, we just did a quick calculation of the amount of thermal impact of single glaze sliding door that's above the balcony. 1,000 times more than we'd ever consider with concrete. So it's kind of a moot point when we've got such absurd loss of heat through.
I think there's I would probably say in there that I think we need to be moving ultimately towards reducing the amount of concrete we start sticking out of buildings to begin with, if we can. When we discussed it in the community of practice, it's recognizing that there's the things that we're proposing aren't making the thermal transfer any worse than they are at the moment. They're not trying to introduce a solution for thermal bridging, which at the section of the BCA, which is trying to solve waterproofing, but recognizing that in order to do the thermal bridging thing, you've got to consider the waterproofing aspect of it. There's a lot of arguments that we have as designers about exposing slab edges in buildings and things, and whether that's something we should just stop doing, which personally I think we should stop doing. I think the amount of thermal exposure that you get from them is a misunderstood thing. There's some data out there which suggests that it's not a big problem. There's some data that suggests it's a very big problem. So while it's a good topic for another conversation, and probably the version looking at Section J and energy side of this, it's something which we recognised is out there, but it wasn't something which was going to have an intrinsic difference in how we were dealing with the waterproofing aspect of it, as far as we were concerned at the moment. The level of surface exposure of concrete with this set down isn't necessarily any different to if you were doing it with a post-fixed hob of concrete or something. So the surface is pretty much the same one way or another.
I think the other point, Craig, is that people have been doing this for up to 15 years.
Yeah.
It's not new.
Oh yeah, it's certainly not a new proposal. But I don't know if that answers your questions, or whether we're likely to go down a Section J conversation rather than a Section F conversation.
Craig, could I make a comment, which is a broad one for everybody thinking about? Because proposal for change not locked in yet. But one thing to keep in mind, the reason why we've all been working on just these few clauses for 4 years, it's tough to get anything changed. And one of the things I'd just like to remind everybody about, what we've adopted is to say, to be lovely that something is better than 100% of nothing. So we're aware that there's still work to be done, and then we'd encourage AIA in active participating that this is just the beginning of change. It's not the end of it. And so now other considerations such as sustainability issues need to become as well. But what we've done is to shift the paradigm of how water is managed is the essential point of these changes.
Thanks, Ross. Look, we've got time for probably one more remark or comment. Michael, this one is again addressed to you from Dennis Moore. Could Michael discuss minimum balcony slab thicknesses? Very briefly, if you can, Michael.
Yeah, sure. So minimum thicknesses are based around, again, it's about the type of design that you're doing. If it's a cantilevered balcony, so the function of that is the type of exposure that you've got. You know, there's things like wind load and things that will have an impact as well. So it's a design function from a load perspective, but then obviously we've just talked about getting integral falls and having enough space to get a step down, which I built up in my slide pack. Having enough set down, having adequate falls is going to change the configuration of the balcony. But the minimum will be governed structurally by its ability to remain stiff and in place and not deflect over time. So it's a case by case basis, but unless there's further to the question, my understanding would be it would go back to the original structural design aligned with the architectural intent to dictate what that cover is. So you need cover to embedded reinforcement. You need the level of stiffness you need for the deflection over time. You need to understand that obviously the distances that you're dealing with and the geometry that you're dealing with. Yeah, I'm not sure if any other comments from Ross or Craig on that.
30 seconds from each of you. Ross, you first.
Just the Elliot's question. Since concrete's becoming the primary element, you recommend some sort of concrete admixture. What my favourite with this is to say, yes, the best admixture for concrete is cement. So it's all to do with water-cement ratio and good curing. So admixtures other than fly ash and other combinations, the so-called waterproofing admixtures, we don't see a role for them in this compared to good mixed design, good curing.
Okay, can I add to that? Sustainable concretes will have lower Portland cement contents in future. They'll be more durable and you'll have a better overall waterproof structure if they're constructed adequately.
Craig, final word to you to wrap up for today.
Okay, I think one of the things that became apparent to us at the last session that we had on Friday with a lot of remedial builders and things was, as Ross just said, this is like the first major step in Section F of the BCA for 40 odd years. So it's a long overdue step, we think. The changes that are there have come about largely because a number of groups of people and organisations and things got together and decided, let's be proactive and try and get this changed. Let's organise. Then it's a way why a lot of the conversation around the remedial stuff was saying, okay, there's mechanisms which you might use, but in a really brutal sense, we're not there to solve your problem for you. The reason these things are in the BCA is because we worked our arses off collectively as a group to get them in there and used every lever that we had. Other people in the industry, other players, other consultancy groups, builders, etc., have to act, organise and put their own things forward and try and see what they can do to work within what's been put together just now to say, here's how we do it, here's how we can do the thing that works for us. But what can't happen is people just to sit back and wait for it to happen. The only way that the change will be made is if everybody actually gets involved. If you care, get involved one way or another and organise and try and make changes, because it's the only way that the change will actually happen is if people get together and do it.
Okay, thank you, Craig.
That's how we got here.
Yeah, okay, great. Well, thank you, all three of you, Craig, Michael and Ross. I think you've given us some great contributions today, and thank you everybody who participated. A reminder that we'll have a recording of this video on our YouTube channel, and we'll let you know when that is. And quickly, if I share my screen, I can show you the QR code once more. And if you'd like to submit something on our Google Forms, that QR code will take you to it, and we look forward to receiving that from you. Ruth, is there anything else that we need to mention before we sign off?
No, I don't believe so. I think you've covered everything. I just also wanted to say thank you to the speakers for their time today. It was very thorough.
Yeah, I agree. All right. Well, it's just gone 2:30, so we're in Eastern Standard Time. So we'll wish everybody a very good afternoon and thank you for joining us.
Thank you, everybody.
Thank you.
Thank
Bye-bye.
you.
Thanks, everyone.
Thank you.
Thank you.